Nitrogen cycle starts with nitrification. Nitrification involves ammonia oxidation and nitrite oxidation. In this process, ammonia gas reacts with oxygen to produce nitrite ion, hydrogen ion, and water. Nitrite ion will further oxidize into nitric ion. The next step is denitrification, where nitrate ion will convert into nitrogen gas in this process. After that, nitrogen fixation will occur. Nitrogen gas will convert into ammonia gas by bacteria. In this process, energy is consumed. At the same time, nitrogen assimilation also takes place, where uptake of nitrates by organisms and enter the food chain. When these organisms die, decomposition by bacteria release ammonia back to the surrounding. This process is known as ammonification. For phosphorus cycle, natural inputs such as weathering and human inputs such as sewage or farmland runoff release inorganic phosphorus into water column. Intake of phosphorus by plants will convert inorganic phosphorus to organic phosphorus. This organic phosphorus will enter the food chain. When these organisms die, decomposition by bacteria will convert organic phosphorus into inorganic phosphorus and release back to the surrounding.
Silicon is a major nutrient that needed by the silicon mineralizers such as diatom, silicon flagellate, radiolarian, and some sponges. The cycle of silicon does not have a gaseous phase. Silicon commonly occurs as silicon dioxide, also called as silica. It cycles through the marine environment, entering primarily through the river runoff. Silica is absorbed by inorganic organisms such as diatom and radiolarian that use an amorphous form of silica in their cell wall. After they die, their skeleton settles through the water column and the silica dissolve. A small number will reach the ocean floor where they will either remain, forming a silicous ooze, or dissolve and are returned to the photic zone by upwelling. There are three types of silicon in seawater. The first one is dissolved silicon. Salicylic acid are utilized by silicon flagellate and radiolarian to create their mineral skeleton and by diatom to develop their external shell. These structures are vitally important as they can protect, amplify light for the photosynthesis and even help these organisms to float in the water column. Secondly, biogenic silica. Biogenic silica also referred to as opal. It is mineralized by diatoms, silicon flagellate, radiolarian, and some sponges. The next one is lithogenic silica. Lithogenic silica can either be accumulated directly in marine sediment as clastic particles or be transferred into dissolved silica in the water column. Being a primary supplier, it helps to supply silica to the water column. Upwelling and downwelling. Upwelling and downwelling is responsible for thermohaline circulation. Upwelling refers to the process by which deep nutrient-rich water rises to the surface of the ocean. It commonly occurs along the coastline and is driven by several mechanisms. Upwelling brings the nutrient-rich water from the deeper layer to the surface, provide essential nutrients such as nitrogen and phosphorus. This supports the growth of phytoplankton, which form the base of the marine food chain. Downwelling. Downwelling is a vertical movement of water in the ocean where surface water sinks to the deeper layer. It can occur due to the wind-driven process, density differences, and subduction. Downwelling can influence the marine ecosystem by limiting the availability of nutrients in the surface water, which can affect the growth of phytoplankton and other primary producers. Coriolis effect is defined as how a moving object seems to veer toward the right in the northern hemisphere and left in the southern hemisphere. When the winds swirl counterclockwise in the northern hemisphere or clockwise in the southern hemisphere, it is called cyclonic flow. But when it is vice versa, it is called anticyclonic flow. Coriolis effect has applied in equatorial upwelling. Equatorial upwelling occurs near the equator when the trade winds converge. Due to the Coriolis force, equatorial upwelling acting on the side of the equatorial current that pull the water in different directions in the two hemispheres. Water immediately to the north of the equator will feel a force pulling to the right, while water immediately to the south of the equator will feel a force pulling to the left. So, this causes a divergence at the surface at the equator, which drag up nutrient-rich water from below.
Impact of nutrient pollutions in the ocean. Pollution means an increase in chemical nutrients in the water column. It contains nitrogen and phosphorus in an ecosystem. Phosphorus is often regarded as the main culprit, in this case in aquatic subject to point source pollution from sewage. The more phosphorus, the more algae. Human has increased the rate of phosphorus cycling on Earth by 4 times with agricultural fertilizer production and application. Between 1950 and 1995, 600 million tons of phosphorus were applied to Earth's surface, primarily on coral plains. Algae blooming. Algae is a microscopic plants that are usually aquatic, unicellular, and lack through stems, roots, and leaves. Algal blooms occur due to high intrusion of nutrients in water columns. It occurs when an algae species competes with other species and reproduces rapidly. An algal bloom can even discolor the water due to large number of algal cells. Harmful algal blooms is a bloom that produce toxins which are harmful to plants and animals. There are 3 types of algal that may bloom, which is cyanobacteria, diatom, and dinoflagellates. So, green algae is believed to have played a major role in the addition of oxygen to the Earth's early atmosphere. Some of the cyanobacteria carry out nitrogen fixation. Besides, diatom is a unicellular. It has a cell wall composed of silica, a glass-like material which comprises of a shell-like structure called a frustule. Dinoflagellates. It have 2 unequal flagella that help them direct their movement. Many of these organisms contain color pigments that cause the water to appear color when this organism bloom. It leads to the term red tide or brown tide. The impact of nutrient pollution is rapidly increase of BOD. Algal blooms limit the sunlight available to bottom-dwelling organisms, cause wide swings in the amount of dissolved oxygen in the water. DO greatly increases during the day but is greatly reduced after dark by the respiring algae and by microorganisms that feed on the increasing mass of the algae. It is high biological oxygen demand. The lower DO, the higher BOD. When DO levels decline to hypoxic levels, fish and other marine animals suffocate. In extreme cases, anaerobic conditions occur, promoting growth of bacteria that produce toxins deadly to birds and mammals. The zones where this occurs are known as dead zones.
So the third impact is decreased biodiversity. So when an ecosystem experiences an increase in nutrient, the primary producers earn the great benefit first. So when the excess nutrient into the surface water, they cause an overgrowth of algae, which block out sunlight and reduce oxygen in the water. This leads to toxic conditions that are caused by a particular blooming algae such as dinoflagellate algae, which may cause massive fish feedback is dead coral, which is coral bleaching. Dead coral is one of the severe impacts of nutrient pollution on coral reef. When these excess nutrients, mainly nitrogen and phosphorus, in the water, they can cause overgrowth of harmful algae on the coral reef, which eventually kills the corals. So, this dead corals can significantly reduce the biodiversity of marine life in coral ecosystems. So, this loss of these habitats can have severe effects on food web and threaten the livelihood of millions of people who relies on reefs for food, economic income, and protection from storms. Therefore, we need to know that corals are very sensitive to changes in temperature, light, and nutrients. So, first of all, we need to know what is coral reef. Coral reef is irregular structures produced by living organisms found in shallow tropical marine waters with little to no nutrient in the water. Here are a few examples that may cause coral bleaching. This one is excessive nitrogen, where corals are unable to cope. Not all corals, because corals are unable to cope with the rising water temperature, which could lead to coral bleaching. Next one is phosphorus starvation. With the use of delay, corals rapidly gain the more limited of phosphate gas. Sources of hydrogen runoff. There are two types, which is point sources and non-point sources. So I will explain the point sources first. So in point sources, the nutrient waste travels directly from the source and to the water. So firstly, the first one is wastewater effluent. For example, industrial waste. This one is runoff from waste disposal systems, and runoff from mines on unsupported industrial sites, and overflows of combined storms and sanitary waste. So for non-point sources, there are four examples that are one out. This one is runoff from agriculture or irrigation, atmospheric deposition over a water surface, and runoff from abandoned mines. Lastly is runoff from pasture and drainage.